Hello, guys. Hi again. I just thought of sharing today something again very basic, Cisco IP phone boot process, which each and every collaboration engineer should at least understand how it works because it's a day-to-day issue that you face whenever you are supporting a customer or anything. And yeah, this is why I thought, why not make some informational video about Cisco IP phone boot up process. I know that most of you might hopefully be knowing about the boot up process, but there are maybe some things asked during an interview question maybe, or during your written examinations, or during your CCNA or CCNP certifications, that these questions are asked. And we really just answer the questions, especially me. I was just knowing just the answers of these questions, but I really didn't know how it really worked in the real life. So I thought of why not to make a small video. And maybe this is just a theoretical video, and it's going to be a bit longer than yesterday. And next time I will try to do the practical implementation of whatever presentation that I'm currently doing. All right, before we go started, I just want to make a small request maybe to all of you. Why not share this information to your colleagues and ask them to join this fantastic group, to share information, to gather information, to get a lot of information about CCNA collaboration, or I'll just not make it CCNA or CCNP, just say Cisco collaboration. You know, it would be a good social platform for all of us to share the information. So just go ahead and share this group with anyone and everyone who is currently in the Cisco collaboration portfolio. All right. So what happens when Cisco IP phone boots up? So even before the Cisco IP phone boots up, let's understand one or two terms about what's really important. So first is power over Ethernet, also referred to as inline power. So what is this power over Ethernet? So my understandings, for my experience, is nothing but the power that's needed to power up the phone and keep it up each and every time, that's delivered over the unshielded twisted pair cables. So basically the LAN Ethernet cable. So the power which is delivered inside this LAN cable, that's nothing but power over Ethernet. So this power over Ethernet is nothing but the power that comes in from the Cisco Catalyst access switches. So why access switches is because the phones are directly connected to this access layer switches. There are different layers of switches that you can have. For example, as per the SRND, you should have access layer switch, which is connected directly to the phone, and then a distribution layer switch, a core switch, you can say, and then this core switch is connected to the router. Right. So this access layer switch also delivers the power to the IP phones. So this is nothing but it uses this LAN cable, a LAN cable, to transfer or to deliver the power that's needed to power up the IP phones. Let's dig a little bit deeper about this, how the IP phone gets power and how the switch knows, this is an IP phone, because this is the very important thing for us right now, because it's a lot of people that they don't want to learn this because it's really confusing. I have been reading a lot of documents, a lot of Cisco support forums, and I got couple of different informations which is really confusing for me as well. So why not, if you find that it's really confusing, let me know in the comments, and then maybe we can discuss this and find a particular information which would be helpful for all of us. So the first question is, how much power can each switch port provide to these telephones? Just find it out. You can get it from a lot of documents from Cisco, and just comment it in the comment section, and let's see. You know, would be a good idea. I thought of that's why I didn't provide the answer to it. I know the answer, but I didn't provide it. I just thought of interacting with you guys and get some more information about it. The next question is there any difference between PoE and the inline power, the term PoE and inline power? So just let me know. Maybe afterwards, I would definitely provide an answer to these two questions. The next question is as well, what kind of PoE cable used to connect the Cisco IP phone with the Cisco access layer switch? So what kind of cable, what kind of LAN cable it is that it is needed, there are different types of LAN cables available. What type, what category, for example, and other things. What kind of cable is really needed to connect the Cisco IP phone to the switches? All right, let's see. Maybe I can't give goodies right now. Maybe later on, if when our group grows, I'll try to get some interesting goodies to make this session interactive, maybe, and long lasting. Yep. All right. So how much power is pre-allocated for each port, to which the phone is connected? So how much power does the switch allocates? So let me answer this. It's like 15.4 watts of powers, and yeah, it's also depend on the power devices. For example, what class of IP phones is connected to the switch port. So if it's a pre-standard Cisco IP phone, then it delivers switch delivers 15.4 watts of power. And for standard based devices or phones, the power allocation is done based on something called as IEEE class. So class, for example, these 600 devices, IP phones, they are class 4 IP phones. So there is a different power distribution for these kind of phones, So I'll put up the links in the description to help you understand, what type of devices need what kind of power, and how is the power distributed from the switch to the phones as well. It's a very extensive topic that I have found. So during my studies in the previous years. Okay, so the next thing is, do you know really how many ports does a Cisco IP phone has? I think everyone, not everyone, but most of them would say yes, I know. And then it's 2 port. Yeah, you are right. It's 2 port that's visible outside, and there is one more port that is inside the phone that you cannot see it from outside of the back panel of the phone. So in all, there are 3 ports for the Cisco IP phone, and the port 1, the first port, is connected to the catalyst switch, or what the other device that can support voice over IP. The second is an internal 10 or 100 Mbps interface that carries the phone traffic, and then the port 3 connects a PC or other device. So this port 2 is the internal interface which is inside the phone, and then this port 2 is used, to carry the phone traffic in and out. So this is really important. So there are 3 ports that an IP phone has currently. And now, how does a switch port know, that an IP phone is connected? So let's say I have a telephone, IP phone, I have connected that to a switch. And now, even before sending a power to this IP phone, the switch should know, which kind of device is connected to me, so that I can, distribute the power. So The short answer would be that it uses a phone discovery algorithm. So Cisco does not to say that disclose this algorithm, because they say that it's a proprietary algorithm. That's why they do not disclose this algorithm. But they said, they have mentioned some steps um, that helps to identify the phones. So I'll put in the links as well for this. So basically, there are two methods depending if the phones are getting power directly from the catalyst switch or from the catalyst inline power panel. So what is inline power panel? So inline power panel is nothing but there would be a switch, and then there would be first two rows in which you can connect the phones, and using the RJ45 cables. And then the below two rows in the same switch is there is a power inline card, which is inside that switch for the inline power. And in backend, you will see that this the last two rows and the first two rows are interconnected. So port 1 is connected to the power supply port 1, port 2 is connected to power supply port 2, and and so on. So this is how the power is supplied from the inline power panel to the port of the switch, to the switch port, sorry. So let's discuss the first method, where there is an inline power card inside this catalyst switch directly, and then there is a power directly provided to the switch ports. So what happens is the port as soon as the port sees that there is something connected to it, the port starts the phone discovery algorithm, by sending a special fast link pulse. So there would be some pulse that's called as a fast link pulse signal that is, it can send it to any device which is connected to it. I mean, the port can send it to any device which is connected to it. And then the port waits to see if there's, a special FLP signal. So fast link pulse signal is forwarded by a connected device. So if the connected device responds to this FLP signals, so the only devices that would do this, they are designed to do this, are the devices that expect to receive inline power. So whichever device needs an inline power would respond to this fast link pulse signal. And then if there is a Cisco 8845, for example, IP phone connected to this 10/100 Mbps Ethernet port, then it will forward this FLP signal back to the 10/100 Ethernet port on the catalyst switch. And then it is capable of doing this. This phone is capable of doing this because it has a special relay. So this phone has a relay. It's a hardware, a small hardware. It's kind of a switch. It has a special electrical switch. So it's a special relay that connects its Ethernet receive pair. So there are two pairs. There is a transmit hardware pair and the receive hardware pair inside the phone. So this relay will connect to the phone's Ethernet receive pair. So receive pair is nothing but the pins on the RJ45 connector. There are receive pair pins and transmit pair pins on these RJ45 connectors. If you want something, let me know. I'll share some more information about it with its Ethernet transmit pair. So then when there is no power, when there is no power in the phone, the relay inside this phone is closed, and once there is a power being supplied, and then this relay remains in the open state. And then since the catalyst switch has received a feedback or received a feedback for this FLP signal that it has sent, then it now knows that it has to power the port, and then It will check its network management processor to check if there is any power available to power this IP phone. And then since the network management processor inside the switch, it doesn't know how much power the Cisco IP phone will need, it uses the configured default power allocation, and later on it will then adjust this allocation based on what the attached Cisco phone tells the switch it really needs. And then port provides power to the Cisco IP phone over pairs transmit and receive, pairs 1 and 2, and then this port is taken then out of this phone discovery mode, and then this port is working as a normal 10/100 Mbps Ethernet port. And then once the phone has booted up, so it has the power, now then it will send a CDP message with a TLV value, something called as type length value object, that will tell the switch how much power it really needs. Now it really will tell the switch how much power it will need. Will it need 7 watts, or will it need 14.5 watts, or will it need 15.4 watts? So now with the help of this CDP message, it will tell the switch, okay, I need 15.4 watts. And you can really see this information in the switch. You can just go onto the switch and say show inline power, and then the interface on which this phone is connected. You will see the exact power that is being assigned to this port by the switch for this telephone. And then the NMP, the network management processor, will then adjust. We'll see this information that's being sent by the phone, and then adjust the power allocation for the port accordingly. So basically, it's a fast link pulse signal by which, after receiving the response from the device, the switch knows that it needs an inline power, and then it sends a default inline power to the phone, and then phone, after powering up, the phone will send a CDP message to the switch with the needed power, and then the power negotiation will happen between the switch and the phone, and then basically there will be an exact power that would be allocated from the switch to the phone. Okay. Yeah, during this process, you can also hit these 2 commands that I have highlighted in yellow, which is debug IL power or debug CDP packets to get more information. All right, what next? After the phone has powered up, it has the exact power that it needs. What is the next thing that the phone will do? The phone will then run the bootstrap loader. That will then, this bootstrap loader will then load the firmware image. This firmware image is actually stored in phone's non-volatile RAM, which is also called as a flash memory. Then the phone will run this firmware image to install all the informations needed to register the phone. All right. After this, once the phone loads the image, after this the phone will send a VLAN request using a CDP protocol to the switch, and then switch will inform the phone about its VLAN ID that it should be in. And then it will, after receiving the VLAN ID, the phone will again send a DHCP request to get the IP address, because it's an IP phone, so it should get an IP address, right? So to get an IP address, either you can configure statically on, based on the host address, you can configure the IP address, but I think for the bigger organization, you will have DHCP. So the second step, what the phone does is send, after VLAN information, is it sends a DHCP request, and it says, okay, I have a VLAN ID. Could you please send me a DHCP server for this VLAN ID so that I can get an IP address for this VLAN ID, Then the switch sends the DHCP information, and then when the phone sends a request to the DHCP server. For example, you can use an IP helper address on the switch. If the DHCP is not configured on the switch itself, then the DHCP IP helper address should help you to relay the information to the DHCP server, and then from there you get the information of the IP address, the subnet mask, the default gateway, and along with this, there is a very important, very important information, which is option 150. What is this option 150? Option 150 is a information where the phone receives the TFTP server information, right? I'll tell you why this TFTP server is being used, or you guys already know about it, you know. So now the phone has the IP address, it has the default gateway, it has the subnet mask, now it has a VLAN ID as well. The next is it will try to, if it's a secure environment, then it will try to first get the certificates using the CTL and ITL files from the CUCM. If not, then phone will request a config file from the TFTP server, and this TFTP server IP the phone has received from the DHCP option 150, right? And for this TFTP, the phone uses the port 6970 or 6972 for receiving the configuration files, you know, from the TFTP CUCM servers. So if you want to see the config files, for example, so it would be something like get slash MAC address of the phone, or IP address of the, sorry, IP address of the TFTP server, colon 6970, right? So this is how it will be. So it will be like SEP dot SEP MAC address dot CNF dot XML, or if it's an encrypted file, it will be dot CNF dot XML dot SGN. You know, so once it can connect to the TFTP securely or unsecurely, the phone will receive the configuration file, and then it will also understand, you know, which is the priority CUCM to which it should send a register request to. You know, so it would be the information from the call manager group in the CUCM, and the top CUCM server in the call manager group will be the CUCM to which the phone should register to. Yeah. And hopefully the CUCM service is enabled on this top priority CUCM server to register. If not, then it will try with the secondary backup CUCM server. I will talk about the SIP phone registration process maybe in my next video, and let you know how the SIP invites and registers and 200 OKs are working when the phone registers, and other things. The important thing here was to understand the port number being used, because I know a lot of times this port 6970 or 6972 is being blocked by the internal firewall, and then phones can't register for long times. So this is the problem. Now, all right. So once everything is done, the phone would finally register. Okay, thank you very much for watching. Please do share this information with your colleagues, and then yeah, we'll talk next time. Until then, goodbye.